In this video, I will show a non-bonus Division B tower that I consider a very good build. This result can be used as a baseline or benchmark for all future Division B towers that I build, specifically when trying to determine if it's worthwhile to build to the bonus design specifications or not. Because the bonus design requires the tower to hold the entire 15 kilograms to get the extra 5 kilogram bonus, it really needs to be noticeably better to risk using that design. Here are my notes from this build with the results blocked out. Compared to my first build in the previous video, I just increased the density slightly across the board. The total mass of the completed legs were 4.4% heavier, and the cross bracing was much stronger at almost 54% heavier. If you recall the previous build, it held just over 12 kilograms, so I wanted to increase the overall strength by about 25% so it would come closer to 15 kilograms. I chose to primarily increase the cross bracing because it was obviously the point of failure in the first build. As with the first build, the first construction step is to use blue painter's tape to carefully tape all 4 marked legs to the jig. You will notice that this time I have not taped the jig to the working surface. That will allow me to glue the cross bracing while the jig is flat on a side. Here is a picture of the jig lying flat on one side ready for the cross member gluing. I found that it was much easier to glue the cross-member pieces in place this way, and more importantly, it was easier to use less glue and keep glue from dripping in the gap where the legs are held in place on the jig. This lowers the chance you'll accidentally glue the tower to the jig, which can be a hassle to deal with. Take a look at how much less glue this technique saved me. If you recall from the previous video, I was using about 0.7 grams of glue before. Now the total glue mass was only 0.36 grams, or about half as much. That is definitely a noticeable improvement. I still like to finish 2 opposite sides of the tower first. Once you have both sides done, stand the jig upright and take the time to sand the surfaces flat of any excess cross-member pieces. Here you can see all 4 sides of the tower are done and the top has been sanded flat. Now it's time to carefully remove the tape on the legs holding the tower to the jig. I like to use a push pin to help start the removal of the tape so you don't risk breaking any cross-member pieces by using your fingers. Here is the completed tower on the test stand where I'm checking the level of the tower in all directions. You can see that it safely spans the 20 centimeter square, so there should be no problems with it being a legal tower. Here's the tower right before testing, and it weighs 4.40 grams. I would recommend you weigh your towers upside down like this for a couple reasons. First, it's the only way they fit on most scales, and more importantly, it's a good check to see if the top of your tower is flat. If your tower doesn't balance like this easily on a flat surface, it's a good sign there is a problem and you should double check your build. Here is the live testing of the tower. With any luck, this one will be much closer to holding 15 kilograms than the initial build, so we can see what this design is capable of. If you remember the best result of the 25 centimeter mini tower build, it had an actual efficiency of 7,372. It will be interesting to see if actual efficiency scales linearly with height like we'd predict from the buckling theory we learned about in that series. Let's see what happens. I'll speed up the video until it gets closer to failure. This tower held 15.891 kilograms, which was very close to what we wanted to have happen. Its actual efficiency was 3,612, or almost exactly half the 25 centimeter mini tower. That means, within reason, you can extrapolate maximum efficiency of this design using height alone. That's pretty handy, as we'll be able to predict good Division C scores directly from this tower as well. It looks like the first failure point of this tower was in the lower cross members. Because this build held over 15 kilograms, I wouldn't look to increase the strength of those failure points, but rather reduce the mass of things that didn't fail. With the non-bonus build, we really don't want to hold over 15 kilograms, as that means it was overbuilt in some areas. The perfect tower here would break in multiple places at exactly 15 kilograms or just under. While this build had an actual efficiency of 3,612, its competition score is only 3,409. To further optimize this build, you want to try and get it to have its maximum efficiency at 15 kilograms or lighter, definitely not over like this tower. This build does show that a 3,600 competition score is achievable, and most likely, the best builds of this season might even approach 4,000. As always though, try and work your way up to those extreme scores. In the next video, I will see if I can build a bonus version of the tower that would be competitive with this range of tower scores. Thanks for watching, and feel free to reach out to me if you have any specific questions.